Hi, I'm Brian, and welcome to CAD That Works. I started this channel because I was tired of seeing CAD tutorials and only make cool looking models with no real world function. I'm an engineer and maker, and I use CAD to fix things that break, build parts that work, and design with purpose. I'll show you how to design functional parts and tools like Onshape and Creo, the kind of stuff that actually gets used, not just looks cool on the screen. This video is the first in a three-part series where I walk you through how I reverse engineered a broken part, modeled it in Onshape, which is my current CAD system of choice, and 3D printed a fully functional replacement. In this part, we'll start by taking a close look
at the broken component and capturing key features we need to recreate it. Here's the issue. This plastic lever off a vacuum food sealer completely snapped off. Without it, the sealing door won't lock and the machine won't function. It's a one-piece plastic part with a keyed bore that fits onto a rotating shaft. The lever arm that actuates the lid snapped off completely, but luckily the bore and the hub section are still mostly intact, which allows us to take measurements and more easily recreate the part. Now, before jumping into CAD, we need to reverse engineer this part. That means taking measurements, understanding the function, and figuring out how we can recreate or even improve it. To save time, I took all the measurements off camera, but I'll show you what really mattered. As you can see, a good method is to create a simple sketch and document the critical dimensions that you need to recreate this part, which I've done here. You don't need to be an artist, you just need to capture the key information. So, on this particular part, the keyed bore is the most critical feature. It needs to mate with the hatch actuation shaft securely and transmit torque to actuate the mechanism. With my digital calipers, I measured the outer diameter and the width and depth of each key slot, and also the lever length so we can get the approximate mechanical advantage that we need for the vacuum sealer. This area here, where the lever broke, is the weak point. We'll keep the original geometry for now, but in a future revision, I'll change that design to ensure adequate strength and rigidity on the 3D printed part. So now we've got what we need: measurements, the function, and a game plan. In the next video, I'll jump into Onshape and model this part step by step, including how to handle the keyed board in broken geometry. So if you're into fixing things with CAD and want to design parts that actually work, hit that subscribe button and follow along.